Yes, Amar. So in the previous class, we have studied electricity chapter. Okay. And in the electricity chapter, we have studied that what is electric current, what is electric current. Have you studied this topic? What is electric current? What is 1 ampere?
So it
What
was,
is
it was taught in the school, but
not here? So where were you?
second it was in the book.
Okay. So this is define 1 ampere. Third one. Okay, so let's start studying.
Yeah.
So Amma, let's start studying that what is electricity. Okay. So you know that the rate of flow of charge is called electricity. Okay. What is current electricity? We can say that the rate of flow of charge is called electric current. Okay. When the electricity or when the charge or the charge start flowing through a conductor, then the speed with which it is flowing means per second how much charge is flowing, that we call it electric current. For example, if 1 coulomb charge is flowing for in 1 second, it is considered to be as 1 ampere current. If 3 coulomb of charge is flowing through a conductor, then we say that the current flowing through it is 3 ampere. Okay. So we can say that the rate of flow of charge, when the electrons start flowing, electrons are the charge carrier. So if electrons flow means charge is flowing. So we can say that rate of flow of charge is called electric current, and the SI unit of electric current is ampere, which is denoted by capital A. The other unit is coulombs per second. Why it is coulombs per second? Because the unit of charge is coulombs and the unit of time is seconds. So we can say that its unit is coulombs per second. Okay. Please note it down.
Yes, sir. So the entire thing, or
What are you saying, Mark?
so I had to write the entire page.
Yeah. No, up to here
Okay.
you have to write.
Okay.
And for the time that you are not using, means writing, please please mute your mic because there is some bring sound is coming.
And so
Done. Now, what is
yes.
define 1 ampere? What is 1 ampere? We can say that 1 ampere current is that current when 1 coulomb of charge. Why? How can we say that? A question from NCERT that 1 coulomb charge, if it is flowing in 1 second, so we can say that here the current is 1 coulomb, and the charge is also, sorry, time is also 1 second. So 1 upon 1 is 1. So we can say that the current flowing through the conductor will be 1 ampere. So we can say in the simple definition that what is 1 ampere? So we can simply say that if 1 coulomb charge flows through a conductor for the time 1 second, if 1 coulomb charge flows through a conductor for the time 1 second, we considered it as, okay, if 1 coulomb charge flows through a conductor for a time 1 second, we said that the current flows through a conductor is 1 ampere. Okay, so please note it down, define 1 ampere.
Yes. Done, sir.
Done. Okay. Now let's move further. So if the question comes to you that calculate the number of electron that will pass through a conductor. So you know that what is charge is carried by? Charge is carried by electrons. Okay, and one electron has a charge of 1.6 into 10 raised to the power 1.6. Okay, the charge carried by electron is minus 19 coulomb. Okay, so if I'm talking about that, the charge carried by an electron is 1.6 into 10 to the power minus 19 coulomb. Okay, charge carried by an electron is the charge carried by electron is 1.6 into 10 to the power minus 19 electrons. So Q is the charge of an electron. We called it E. Okay, now you know though, if one electron passes through a conductor, that it is going to have 1 into 1.6 into 10 to the power minus 19 coulomb charge.
19.
Yes. And if it is 2 electron passing through it, the total charge will be 2 into 1.6 10 to the power minus 19 electron per. And if n number of electron pass through a conductor, then the charge will be 1.6 n into 10 to the power minus 19 coulomb. Okay, and this is we call charge of electron. The total charge flowing through a conductor can be defined as n into E, where n is the number of electron, E is the charge of an electron, and Q is the total charge. Okay, so we can say that n is the number of electron, E is the, what is E? Is the charge of electron, that is 1.6 into 10 to the power minus 19, that is charge of electron, and Q is the total charge. Okay, so we can have formula, we have it I is equals to Q upon T, and that's case then Q is equals to N into E. So we can say that the other formula for I will be N into E by T. Okay, Saima, why are you late? Saima, why are you late?
So one electron. Hello, sir.
Yes, one electron is going to have this charge. Have you
Yes,
noted
sir.
this one?
So one electron is. So once I'm still writing, but one electron is 1.6 into 10 to the power minus 19 coulomb.
Yes. One electron charge is equal to 1.6 into 10 to the power minus 19 coulomb. This is the charge of one electrons. Okay. Okay, should I move forward?
Yes, sir.
Okay. So if the question comes that the question is calculate the number of electrons that will pass through a conductor per second in 8 coulomb when 8 coulomb of charge pass through it for time 5 seconds. What should be the answer? Calculate the number of electrons passed through 8 coulomb charge, okay, per second.
So 8 by 5.
So you know that I, what will be the value of I? I is 8 coulomb. I is C upon Q. Sorry, I is Q upon T. So I means the current. So you can say that I is equals to Q, and Q is, what is total charge given to you? That is 8 coulomb, and how much time it is taking? It is taking 5 seconds. So we can say that the current flowing through the conductor is 1.6 ampere. Okay. Okay. So it means that if I'm taking that 2 ampere current pass through a conductor. So it means 2 coulomb charge is passing per second, is passing per second, per second. Okay, if I'm saying that 3 ampere current flows through a conductor, it means 3 coulomb charge, 3 coulomb charge is passing per second. Okay, 5 ampere means 5 coulomb charge is passing per second. So if I'm saying 1.6 ampere current is flowing through a conductor, it means 1.6 coulomb charge is passing through conductor per second. Okay, understood? Understood? Understood?
Yes.
Shaima, why are you not responding? Are you there?
Yes, sir.
So if I'm talking that if 1.6 ampere current is passing through it, then it is asking how many number of electron is passing per second. Okay, means how much electrons are going to carry this 1.6 electrons. So we have I is equals to 1.6 ampere, and it means equals to Q upon T, and it is asking per second. In the question it is being asked per second. How many electrons will pass through a conductor per second? Means time is 1 second. Okay, so here the time is 1 second. Okay, so you will write 1.6. So you can write I is 1.6 and Q is N into E upon T is 1 second. So N you need to calculate. E is 1.6 into 10 to the power minus 19 upon 1 into 1.6. Calculate the value of N. Calculate the value of N.
Can you repeat again? I couldn't understand.
Okay, let me explain it one more time. In the question, it is being given that 8 coulomb charge passes through a conductor in 5 seconds. So this is Q value is given to you. Time is total time is 5 seconds passes through it. Okay.
Yes.
So 8 coulomb charge passes in 5 seconds. So how many coulomb charge is passing per second? Because the number of coulomb charge that is passing per second is called current. So we will take that if 8 coulomb charge passes in 5 seconds. So there will be 8 upon 5, that is equals to 1.6 coulomb charge will be passing per second. So we can say that 1.6 ampere current is passing through it. Okay.
Yes.
Now we know I is equals to Q upon T, and this Q is also equals to N into E. So in place of this Q, we can write N into E by T is equals to I. I is being given that it is 1.6 because if 8 coulomb charge passes in 5 seconds, so in every second 1.6 coulomb charge will be passing, and the charge that passes once in every second is called current. So if 1.6 coulomb charge is passing per second, it means 1.6 ampere current is there. Okay.
So what is? So I'm not sure what Ne is though.
N is number of electron.
Oh.
Number of electron. N is number of electron, and E is the charge of an electron. That is equals to 1.6 into 10 to the power minus 19. Okay. So we'll write here 1.6 is equals to N is the number of electron into E is the charge of electron upon T is the time. 1.6 is equals to number of electron is, we need to find out, and charge of electron is 1.6 into 10 to the power minus 19 upon time is T. Time is 1 second because it is asking per second. Okay. Per second means time it can take 1. So this N will remain here and this will comes down. So we'll write 1.6 upon 1.6 into 10 to the power minus 19 is equals to N. So this will cancel out, and this 10 to the power will goes to upside, and this will become 10 to the power positive 19. Okay. Understood?
Yes, sir.
Please note it down. Note it from here. First write down the question. First write down the question. Done? Done?
Done, sir.
Okay. You also? Am I done?
Yes, sir.
Okay. Now we're just going to study the relation between let's study what is potential. What is electric potential? Electric potential. Okay. So we can say that electric potential can be defined as the amount of work done in moving a unit charge, positive charge, from infinity to a point Okay. So what is electric potential? Let me explain you. We can say that we are going to have its definition. Okay? For example, if I ask that what is the definition of 1 second? So uh, we can say that it is the time taken by the light to travel particular amount, means that in this amount, that what are the distance the light is going to cover. Okay, that is 3 into 10 to the power 8. Okay, approximately. So the distance covered by the light in this seconds, we called it, in this part of second, we called it 1 meter. Okay, so there is a definition of 1 meter. There is a definition of 1 kg. Okay, that is the mass occupied with this one. Okay, so we can say that there is also a definition of electric potential. And what is that definition? That is simple. It is the amount of work done. You need to memorize this one simply. It is the amount of work done in moving a unit positive charge, positive charge from infinity to a point in an electric field. An electric. Okay, note it down here. And what is electric potential difference? Electric potential difference. Both are going to have the definition. So what is electric potential difference? It is the amount of work done, in moving a unit positive charge from point A to point B in an electric field. Okay, so here it is from infinity to a point, and here is from point A to point B. Because there is only a difference. The same are going to have the definition, but here there is a minor difference. In electric potential, we have a definition from amount of work done in moving a unit positive charge from infinity to a point in electric field. But here in electric potential difference, we have definition. It is the amount of work done in moving a unit positive charge from point A to point B. Okay. Got it? Got it? Note it down, please. Note it down. Done, noted, Saima? Amar,
Sir.
noted? Noted?
Yes.
Okay. Now, if I'm talking about that, this one, were you writing?
Yes, sir.
Okay, noted.
Done, sir.
Okay. Now, the SI unit of both electric potential and electric potential difference. Electric potential difference is same. That is volt, denoted by capital V. Denoted by capital V. Okay. So V is volt. Okay. It is denoted by capital V. So the question comes that define 1 volt. The question comes define. So if I ask you that what is the definition, so you can define that volt is equals to work done upon charge. Work done upon charge. Okay. So we can say that
So what does work done mean?
work done means we have written in the definition that it is the amount of work done in moving a unit positive charge. So what is that work done that is being used? Means the energy. We can say that energy that is being used. Okay. To
Oh,
to move 1 coulomb charge means per coulomb charge. So this is called electric potential. So you can define it electric potential. Denoted electric potential. Electric potential can be defined as work done upon charge. So we can write the definition of this one is work done. Electric potential is represented by V, and work done is represented by joules, and charge is represented by coulombs. Okay, so here electric potential has a unit that is joules per coulomb. So this is another unit for volt, that is joules per coulomb. Now the question comes define 1 volt. Define 1 volt. So we can define 1 volt that when this value and this value becomes 1, if you have V is equals to 1 upon 1 means 1 joule and 1 coulomb charge. So then you're going to have V as 1 joule per coulomb. So we can say that then it is said to be 1 volt. So what I'm saying here is that when the definition for 1 volt, when 1 joule of work is done in moving a unit positive charge, and 1 joule of work is done in moving a unit positive charge means 1 coulomb charge. Unit positive charge means 1 coulomb charge from infinity to a point. It is said to have electric potential of 1 volt. When you're done, please let me know.
Done, sir.
Other Amar, done?
Yes, sir.
Okay. Now we have a relation that V is equals to W upon Q, work done upon charge. Okay. And you know that we can write V into Q is equals to work done. Okay. And you know that Q is equals to N into E. So V is equals to N into E is also equals to work done. Okay. Work done. Okay. Understood? So if the question comes to you, calculate the work done in moving 10 raised to the power 25 electrons across a potential difference of 2 volt. Across 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 a potential difference of 2 volt. So do this one. Done. So what should be the answer? What is being given to you? Number of electron is being given, that is 10 to the power 25. W is we need to find. Okay, V is given to you, that is 2 volt. Okay, so we have the formula V is equals to W upon Q. Okay. And we have this Q will goes to that side. We have V into Q is equals to W. V is
Sir,
2
the answer is 2
and
into
Q.
10 raised to 25.
No, Q is not given to you. N is given to you. So we have studied the previous formula. Q is equals to N into E, where N is the number of electron and E is the charge of electron, that is 1.6 into 10 to the power minus 19. So write it, V is 2 into 10 raised to the power, N is 10 raised to the power 25 into 1.6 into 10 raised to the power minus 19 is equals to W, and W is equals to, this will become 3.2 and 25 in positive, and this one will become 10 to the power 6. 3.2 into 10 to the power 6 joule. Okay.
Yes, sir.
Understood? Please note it down. Done?
Done, sir.
Okay, let's move further. Next question, calculate the work done in moving 1.3 coulomb charge across a potential difference of across a potential difference of 3.9 volt. Done? What's the answer? Work done is equals to charge into volt. So product this 1.3 into 3.9. What is the answer come? It is that will be in joules. 3 point
550.7.
1.3 into 3.9. That will be greater than 4.
5.07.
5.07. Okay. 5.07. Okay. So now you understood.
Yes, sir.
Now we have studied I is equals to Q upon T. We have studied I is equals to, we have studied Q is equals to N into E. We have studied N into E is equals to T. We have studied V is equals to W upon Q. Now, what is the relationship between this current and potential difference called? So we will talk about relationship between between current and potential difference. Potential difference. Okay. So if I talk about that, what is the current and what is the difference between potential difference? So it is given by the Ohm's law. Ohm's law. Ohm's law gives the relationship between electric current and potential difference. And what does it say? It says that the current flowing through at constant physical condition, the current flowing through a conductor is directly proportional to the potential difference across its end. At physical condition, the current flowing through the condition at constant physical condition, the current flowing through a conductor is directly proportional to the potential difference across its ends. So what does it say? It says that current is directly proportional to potential difference. If we have maintained the physical condition like temperature, pressure constant, then if we increase the current, then potential differences always will automatically increases. Okay, understood? Understood?
Yes, sir.
So please note it down. Please note it down. Done. Noted.
Done, sir.
Amma, done.
Yes, sir.
So if I having V is directly proportional to I, it is saying more the V, more will be the I. So we can say that V is equals to I R. I R. We from proportionality side when we change something, so we can say that we use some constant. We can say that where R is where R is where V is potential difference, I is current, and R is constant and called resistance of the conductor. Resistance of conductor. So what is resistance of the conductor?
R.
Hmm? You can write one more time. Y is directly proportional to V is directly proportional to I. Then we have some constant, V is equals to IR. Okay, got it? Noted? Please note it down. Done?
Done,
Should I
sir.
move? Okay. So if it is being asked that what is resistance of the conductor? What is the resistance? What is resistance of the conductor? So you can say that it is the property of a conductor by the virtue of which it resists any it resists the flow of charge, the flow of electric current through it, electric current or charge through it. Note it down, please. The question comes, calculate the resistance of the conductor when 2 coulomb of charge flows through it for 5 seconds across a potential difference across a potential difference of 3 volt. Solve it, please. Amar, are you there?
Yes, sir, I'm writing it right now.
Okay, noted. Please note it down. Done?
Yes, sir.
What's the answer?
This one.
What's the answer for this question?
1 second, sir.
Calculate the resistance of the conductor when 2 coulomb charge flows through a conductor for 5 seconds across the potential difference of 3 volt.
So is that 5 second or 8?
5
1
second.
second.
5 second.
1 second, sir.
It's very simple. V is equals to IR, then R is equals to this I will goes down. This will be V by, okay, V by I. Okay. Understood? So what is being given to you? I is not given to you. Okay. So I, you know, I is Q by T. You can write I is equals to V upon Q by T. Okay. So this T will goes up and this form V upon and this by Q and this will be T. Okay. This is the new formula. Okay. Understood? Or you can
If
simply,
you answer 4.6 into 10 raised to 19.
no. What is being given to you in the question? It is being given that 2 coulombs and this is time is given to you and potential. So please write in summary. 3 V is equals to 3 volt given. Potential difference. Time is 5 seconds given. And here Q, the charge is 2 coulombs given. 2 coulombs. Charge is Q 2 coulombs given. So here charge Q is 2 coulombs. Okay. So now you have R, you need to calculate the resistance. So you know the R is equals to V upon I. So you have V, but you don't have I. So you can calculate the I by this formula. I is equals to Q by T. What is Q? Q is 2 upon 5. That is 0.4. Okay. So then V is, what is V? V is 3 by 0.4. This decimals, you will remove the decimals and you will get 30 by 4. You will get 30 by 4.